Alright people, welcome back. Thank you for watching this video. Today we're going to do measuring volume. Now this is going to be chapters 7.03, so you would have already watched 7.01 and 2. We're going to talk about volume and what is volume and how do we use it in math. So first, a nice little definition. Okay. The volume of a solid is the amount of space occupied by the solid. It's measured. So volume is measured in cubic units. Alright, so for example, we have cubic meters, we have cubic centimeters, we have cubic millimeters. So this can be written as meter with a little 3, cm with a little 3, or mm with a little 3. Let's go ahead and let's try and convert our units over here. So we'll start with millimeter cube there, centimeter cube there, and meter cube there. Okay. Now, which one's really big? Well, that's sorry. Let me change that to a 3. Let's be a 3. That's the biggest one. That's the obviously small, and that's smallest. So, like before, we're going to go this way. I'm going to multiply by something. And then when we go this way, we're going to divide by something. Now, what do we divide or multiply by? Let's think about this. How many centimeters are in how many millimeters are in 1 centimeter? Well, there's 10. But we're not talking about just centimeters or just millimeters. We're talking about cubic units. So to the power of 3. So it's actually times 10 to the power of 3, which is also 1,000. Right? 10 times 10 times 10 is 1,000. So over here we do divide by 1,000 or divide by 10 cubed, 10 to the power of 3. Now what about going from meters to centimeters? How many centimeters are in 1 meter? 100. So we're going to times by 100, but because it's cubed, we're going to cube the 100. So we do 100 times 100 times 100. It's actually 1,000,000. Divided by 100 cubed. So this is your little conversion table of how to convert between your volume units. Okay. So let's do 2 examples. Example 1. Convert 50,000 cubic millimeters to cubic centimeters. Well, let's go over here. We're going to have to divide it by 1,000. So we do 50,000 divided by 1,000. Remember how we cross off the zeros? 1 0 there, 2 zeros there, 3 zeros there. You get 50. Okay, example 2. This is a little bit more real life. What would be the correct volume for a tissue box. (200 cubic meters, 250 centimeters, or 200 cubic millimeters. Which one of these? Well, think about how long a meter is, and then make that a box. That's how big 1 cubic meter is. So obviously, a tissue box is way smaller than 1 cubic meter. So it can't be this guy here. What about these two? Think about 1 centimeter and make it a cube. So this is not an exact, but this over here, that's roughly 1. This die, sorry, because it's only 1. This is roughly 1 centimeter or 1 cubic centimeter. So 250 of these, probably. Let's just double check with that one. Well, 1 cubic millimeter is that small. Alright, so this 200 of those, no way it's going to fit a whole tissue box. So it has to be this guy there. Okay? Now, onto our work. Work for this chapter is 7.03 for the new book. We got page 180 to 181. For the old book, we have page 176 to 177. Okay, on to the next one. Alright people, we're going to move on to volumes of prism. Prisms, okay? This is going to be 7.04. So, what is a prism? You might ask yourself this question there. What is a prism? It's a solid with identical ends. It's probably a really simplified way, but it's easy to understand. So a solid with identical ends. So a prism, it also needs flat sides. With flat sides and identical ends. Okay. So sometimes you can define prisms by the shape of the ends. For example, a triangular prism. Will have a triangle at one end, and then it extends out to another triangle at the other end. Now, there is a very, very nice shape that you've seen before. Oh, look at this. Look, triangle on that side, and triangle on that side. Triangular prism looks very, very similar to a Toblerone. Alright, we got rectangular prism. We have a rectangle on one side. Oops. And then we have a rectangle on the other side. Very similar to a tissue box. Okay, so I'm gonna now give you a formula for the volume of prisms. So this works for any prism. Okay. Volume equals A times H. Ooh, seems like it's too simple. Well, let's break down what these mean. Okay, so the V obviously means volume. That's what We're always trying to find the A. The A is the area of the identical end, or the base. Okay, so for example, A for the triangle would be this bit there. A for the rectangular prism would be this bit there. Okay, if we had a shape that looked like this, looks like a sponge, A would be this here. Okay, and H would be the height of the prism. This guy there, or this guy there, so that from one side of, from one end to the other end, from one end to the other end. Okay, so from one end to the other end, from one end to the other end, from one end to this end here, which is down at the bottom. So depending on how it's drawn, make sure that you get the correct height. Okay, let's do a few examples to help you out there. Okay, example 1. Find the volume of this prism. Okay. A little bit of sponge. Alright. So you see how it's the same on the top and the bottom. I know my drawing's not that good, but I think you can see it. So this is already given to you in the question. Area of the base is 65 square centimeters. We'll do a little arrow there. That's 8 centimeters. So our formula is V equals A times H, sorry, big A. And the big A is the area of the base. In this case, they already give it to us. And the height, well, it's there. So V equals 65 times 8, which you can put in your handy dandy calculator. It's 520 cubic centimeters, because it's a volume. What about if we get a rectangular prism? Okay, so example 2, same question. So find the volume. Same question as above. Okay, this is going to be 40 millimeters. This is going to be 9 millimeters, and this is going to be 12 millimeters. Alright, so we're going to find that, well, it's actually still V equals A times H. So now we can actually, this is pretty cool because we can pick where we want our area of our base to be. It could be that one, it could be that one, or even could be that one. We can pick any one, and the reason is because we have the measurements for all the different sides. So let's pick that one as my base, and I'll actually show you. How to get the measurements of the area. Okay, let's take this and let's put it out there. Okay, so it's the same shape. I'm just drawing it here so you can see it. Now what is going to be, well this here, it's a rectangle, right? What is going, it looks like a parallelogram, but that's because of how it looks like, but in real life it is a rectangle. So what is the length? What is this length here? Well, let's see, that's 40, and that means that's also 40, so we got 40. What about this here? Well, we don't know what that is, but we know that's 9, and this is the same as that, so that's going to be 9. So the area is going to be 40 times 9, which is going to make it 360. Now, if that's my area, where's the other side? The other side is actually there, right? This is where the other side is. It's down the bottom. So from there to there, what's my height? Or h? Well, it has to be 12. So my volume is, we got the area, which is 40 times 9 times 12. You can use your handy dandy calculator. Use your handy dandy calculator. 40 times 9 times 12. You can get 4,320. Now what do you notice about these three numbers? Well, this is actually the height of the prism, of the rectangular prism. This is the width, and that's the length. So very special for the volume of a rectangular prism. We can go the length times the width times the height. Only because the lengths in these two actually make the area of the base. Alright, so we're now done with that example. We're going to do exercise 7.04. That starts on page 185. And we're going to work until 187. This is for the new book. For the old book, we have, so this is for the new book. For the old book, we have page 179 all the way to 182. That's the old book. These are arrows. Thank you very much, people.